Hello there! Now it's time for another standard optimization problem. Find the area of the largest rectangle that fits inside a semicircle of radius 10. One side of the rectangle is along the diameter of the semicircle. So we're going to do what you always do if you don't know how to solve a problem. We're going to draw a picture. Okay, let's draw this picture. So I want a semicircle, so I'm going to draw a set of axes here, and I'm going to make my semicircle. Here it is. And the semicircle has radius 10, that's right. And I have a rectangle inside here, so let's draw my rectangle. There's my rectangle, and you know what I'll do? I'll call this X, and I'll call this Y, and we want to find the area of this rectangle. Well, the area of this rectangle is going to be 2x, 2 times x times y is equal to the area. Now we got to keep our eye on the goal, so we must determine your goal. Well, remember, let's look at the question again. So the question says find the area of the largest rectangle. So if I look at this, I want to find a value. I want to find a value for x, and that's going to give me half the long side of the rectangle, and probably I can find the y, and then from that I can find the area. But we can't have any old numbers for x and y. We need to find constraints. So let's look at the picture. So here's our picture, and we have the circle of radius 10. Now I know something. I don't know much, but I know something. I know that the formula for a circle is x squared plus y squared equals 10 squared. There we go. And so here we go. This gives us some relationship between x and y. Also, we know that x is always greater than 0 and y is always greater than 0, because if we're looking for the largest area, well, x being 0 and y being 0 isn't going to give us a very large area for a rectangle. So we can actually say a little bit more than this. What can we do? Well, we can go ahead and solve for y here. And so I'll get y squared is equal to 10 squared minus x squared. I take the square root of everything. Everything's positive. So y is equal to the square root of 10 squared minus x squared. And we have something else. We have one more equation here. We have that 2 times x times y is equal to the area. So this is a constraint, this is a constraint, and this is from our goal. But now we have too many letters, so we need to solve for a single variable. All right, so we look at our constraints here, and I have all these variables around, but it looks like what I can do is I can just simply, I've already solved, got a little ahead of myself perhaps, but I can just write 2 times x times, now plug in for y, the square root of 10 squared minus x squared equals a. And if you remember what our goal is, we want a to be as large as possible. And now this is calculus class after all, so we should use calculus to find extreme values. All right, so let's do it. So here we have our formula for area, and we want to maximize area. And one of the best things to do when you want to maximize something is you take its derivative. So a prime is equal to, well, look at this. I'm going to have to use the product rule here. So it's going to be 2 times the square root of 10 squared minus x squared plus 2x times 2, because this is going to turn into, this is to the 1/2 power, goes down to 1/2, times 10 squared minus x squared to the 1/2 power times the derivative of the inside that I'm going to write up here. No problem with that. That's going to be negative 2x. Aha. You know what? I think I can simplify this just a little bit. I can cancel these and then have a prime is equal to 2 times the square root of, I guess I can write 100. I've been writing 10 squared the entire time, but I can go ahead and write 100 plus, or minus 2x squared all over the square root of 100 minus x squared. And so remember, what we should do is we should look for critical points. Well, one critical points are when the derivative is equal to 0 or the derivative is undefined. Now the only time the derivative can be undefined is when x is equal to 10. Look, if x is equal to 10, then we have a very flat rectangle. No area. So that's not going to be a maximum point. So assume x 10 is greater than x and x is still greater than 0. That's what we're going to assume. And if I make this assumption, then then there are no other critical points except for where perhaps this thing equals 0. So let's see if we can figure out when this thing equals 0. So 0 is equal to 2 times the square root of 100 minus x squared minus 2x squared all over the square root of 100 minus x squared. Well, I can multiply everything under the sun by the square root of 100 minus x squared, and that will take care of this square root in the denominator. And here we're going to get 0 is equal to 200 minus 2x squared minus 2x squared. 0 is equal to 200 minus 4x squared, which tells us, look, I can divide everything by 4 if I want to, which tells us that, I'll go ahead and divide everything by 4. What's 200 divided by 4? What's 50? 0 is equal to 50 minus x, right, and squared, and so 50 is equal to x squared. And so this tells us that the square root of 50 is equal to x. So if the square root of 50, let's start here, the square root of 50 is equal to x, what's that tell us about y? Well, remember, y is equal to the square root of 100 minus x squared. So y is equal to the square root of 100 minus 50, the square root of 50 squared, that's minus 50. So y is also equal to the square root of 50. And now if we recall from our picture, 2xy equals the area. So 2 times the square root of 50, that's x, times y, square root of 50, is equal to, well, square root of 50 times square root of 50 is equal to 2 times 50 is equal to 100 square units. And there we have it, folks. We've solved a classic calculus problem using the methods of calculus, obviously. And I'm happy we did it. I hope you are too. Let's go do some more math.